gonna hide. I believe it's a recording. So what I found is that as I'm grading your pretest perfect square, and what it means by square and what it means by cube, that's an overall problem. So let's fix that. And there are two different stories. If I have, okay, I cannot write, okay, 2 plus 2 plus 2 versus 2 times 2 times 2. They are different stories. And therefore every abbreviation, mathematical notation is different. If 2 is added 3 times, we write that 2 times 3. 2 is added 3 times. Whereas if 2 is multiplied 3 times, we are going to write 2 cubed. So when you have an exponent, that means it is multiplied. When you have a multiplication, that means it is being added. And let me give you some nomenclature for this one, which is, where are you? I can see my, okay, here we go. The 2 in the bottom, it's called base. And here, the 3 on the top is called exponent. And together, we say this is power. All right, so let's go over, since we have this one, let's go over something else. Let me make it a little bigger. Okay. All right, let's make it a little bigger. Okay, so we have something called the perfect square or perfect squares. 1 is perfect square because 1 times 1 is 1. Therefore, 1 is perfect square. 2 is not perfect square because we need to have two numbers. We need to have two numbers. When you multiply, that becomes 2. What is that number? So when it comes down to the perfect square, these numbers has to be these numbers. What I mean by these numbers, these two. These are called square roots. Square roots must be whole number. If square roots are whole numbers, then 1 is perfect square. 2, there are no two whole numbers. When you multiply, it becomes a 2. 3. So what is two numbers? They are exactly the same. At the same time, they are whole numbers or integers. They become 3. Not that I know of. All right, 4 is a 4 perfect square. 4 is perfect square because I can find the two whole numbers or integers. 2 times 2 is 4. Therefore, 4 is said to be perfect square. So it is going to be perfect square because we have two square roots. We have a square roots, and square roots that happens to be whole number or integer. So I should have said integer. Probably integer is, no, you know what? Integer is more better way of saying it. All right, moving on to 5. So if I have a 5, what is an integer or whole number that exactly the same when you multiply that become 5? I don't have that. I don't know what that is. All right, do I have a 6? Do I have a 6? Happens to be the same number and become a 6? What is that? I don't know. What about 7? Do I have any number that are exactly the same when you multiply become a 7? I'm not sure. If you find one, let me know. And 8. So you need to have the same numbers and integers or whole number. When you multiply become a 8. What is that number? I don't know. 9. You know what? I can't find the two numbers that when you multiply it become a 9. What are those numbers? 3 times 3? 3 times 3 is 9. Therefore, 9 is perfect square. 9 is perfect square. And these 3 times 3, they are said to be square roots. Square roots of 9. So I'm going to prove it to you what it means by I cannot find one. So if I open my calculator, right? Yes, I opened the calculator. Okay, so let's find out. Oh, let's find out. Okay, and two numbers when you multiply become a 2. So 1 times 1 is 1. So let me go by 1.1 times 1.1. There's a 1.21. That's not 2. So maybe 1.5 times 1.5. That's a 2.25. That's bigger than 2. So it has to be smaller than that. So 1.4 times 1.4. 1.96 is very close, but not quite 2. So what about 1.41 times 1.41? 1.9881. So I could go, what about 1.42 times 1.42? That is equal to, that's a 2. So it has to be 1.41. But 1.41 times 1.41 is still not equal to 2. So I need to find, you know what? 1.41. Oh, I'm sorry. 1.41. Wait a minute. That is not 1.41. So 1.41 times, so 1.41 times 1.41 was 1.9881, still not 2. 1.419 times 1.419, would that be 2? No, it's a bigger than 2. So 1.418 times 1.418, would that be a 2? It's bigger than 2, so I guess 1.417 times 1.417. Oh man, that's still bigger than 2. So 1.416 times 1.416. Still bigger than 2. So 1.415, 1.415. Now we are going to use square sign. So I'm so tired of writing 1.41 times 1.41. So I'm going to use this square notation. That means 1.415 squared means 1.41 times 1.415. I'm going to enter that. Okay, that's still bigger than 2. So I'm going to type 1.414 squared. That means 1.414 times 1.414. Enter. Okay, very close, but it's less than 2. It's not 2. So what about if I go one more decimal places? 1.4149 squared. Oh, it's bigger than 2. So I'm going to go 1.4148 squared. That'll be still bigger than 2. So 1.4147 squared, which is still bigger than 2. So I go by 1.4146 squared. Oh, still bigger than 2. So 1.4145 squared. Still bigger than 2. So 1.4144 squared. Still bigger than 2. 1.4143 squared. Still bigger than 2. 1.4142 squared. Now, it's less than 2, but it's not 2. It's very close to 2, but it's not 2. So I could go 1.414. It's smaller, so I'm going to go 1 decimal low, but 9. And let's make it, that works. Enter. Oh, man. It's very close, but still not 2. And you guys see the idea. I do not have, when it comes down to this, I do not have a number that when you, same number, when you multiply, it become a 2. I just don't have it. We just don't have it. And this case, these guys have a name. So I'm gonna give you these numbers. I'm gonna go over here, and they have a name. You see these fractions? Oh, do you see this fraction? They don't repeat 999,33356. They are going to go forever, but they don't repeat. It's called a non-repeating decimal. And when you have a non-repeating decimal, and trying to find the square roots of 2, we suddenly found out non-repeating decimal. That's called irrational numbers. So I'm gonna give you a new definition.
Mrs. Chacon,
We found out that
Mrs. Chacon, please dial 80901.
all right. We found that oh, never mind. I'm gonna go bottom here. So we found out these two number. We're trying to find these 2, right? It's going to go cube forever. So there is no perfect square. In other words, perfect square roots. Because we found out that in order for you have, there is no same numbers. The short sense. We cannot find whole numbers. We cannot find integer that goes near. That goes here and that goes here. It has to be decimals, and they are non-repeating decimals. So for this one, we found out there are non-repeating decimal. They are non-repeating decimal. They are not integers. They are not whole numbers. And when that happens, because of that, they are not perfect square. So 2 is not perfect square. 3 is not perfect square. Right, I'm gonna add another page. Add page. Okay. And we are going to go over here. Right, so let's start here. 1 is perfect square because 1 times 1 is 1. 2 is not perfect square. 3 is not perfect square. 2 is not. 3 is not. 4 is perfect square because 2 times 2. 5 is not. 6 is not. 7, no. 8, 9. 9 is perfect square because 3 times 3. 10 is not. And let's go to 11. 11 is not. I don't know what those are. Can you find the 2 whole numbers, integers? When you multiply, it become 11? I don't know. 12. I don't think so. I don't know. There's nothing. 13? No. 14? No. 15, no. 16, yeah, because I know 4 times 4, they are both integers, whole number. When you multiply, it becomes a 16. So 16 is a perfect square. 17, 18, 19, no. 20, no. And do you see the pattern here? 1 times 1 is perfect square because it's 1. 2 times 2 is 4. 3 times 3, 4 times 4. I'm going to write 5 times 5. Therefore, 25 is a perfect square. What about 6 times 6? Therefore, 36 is perfect square. 7 times 7, 49 is perfect square. 8 times 8, 64 is perfect square. 9 times 9, 81 is perfect square. 10 times 10, so 100 is perfect square. 11 times 11, therefore 121 is perfect square. 12 times 12, therefore 144 is perfect square. And 13 times 13, therefore 169 is perfect square. And 14 times 14, 196 is perfect square. And 15 times 15, therefore 225 is perfect square. So all I did was trying to find, see, 1 times 1, therefore 1 is perfect square. 2 times 2, therefore 4 is perfect square. And 3 times 3, therefore 9 is perfect square. And those numbers in between this perfect square, 2, 3, 5, 6, 7, 10, 11, those numbers are not perfect square. They are not perfect square because I cannot find any number that happens to be a whole or integer and multiply become a 2. So I'm going to write over here, no two integer apply here. Okay, so that's the idea of perfect square. And I'm gonna go back to my notes again, add one more page. Okay, and this is what I found out during your pretest. Your pretest was, what is a square? What is a square? SQUA square of 6. That means 6 squared, which means 6 times 6, therefore 36. What is square of -6? That means -6, quantity of -6 square. So I'm going to multiply -6 times -6, parentheses here, parentheses here. Negative times negative become positive, so I'm not even going to bother to write positive sign, but I'm going to write once. 6 times 6 is 36. It is 36. So notice, when you square of a 6 and square of -6, they are both 36. Square of 6 and square of 6 and square of -6, they both have positive 36. So let's go over another one. If I have a square of 5, that means 5 squared. That means 5 times 5, which is 25. Or square of -5 means -5 squared, which means -5 times -5. So negative become positive. 5 times 5 is 25. I want you to notice square of 5 and square of -5, they both have positive 25. And there was another one with the fraction problem. So I have a square of 2 over 3. That means 2 over 3 squared. That means 2 over 3 times 2 over 3. When you multiply fraction, remember you multiply numerators together and denominators together. So I have a 2 times 2 over 3 times 3, which is 4 over 9. Right. So let's go another one. Square negative 2 over 3 will be, that means negative 2 over 3 square. That means negative 2 over 3, quantity of negative 2 over 3 times quantity of negative 2 over 3. We all know that already. Negative times negative become positive. I'm not even going to write the positive sign, but 2 times 2 over 3 times 3, which is 4 over 9. Notice square of 2 over 3 and square of negative 2 over 3, they both give you at the end positive 4 over 9. And I hope this video helped you guys throughout the process. And we will see more about this one during the class period. Okie dokie.